Thank you for joining this lesson. We're going to handle errors and approximations. Percentage error, whereby subtraction has been involved, as shown here. We are told that the values of A are 2.5 and that of B 6.15. Then we find the percentage error in B minus A. So remember, A has been recorded to an accuracy of 1 decimal place, whereas B is recorded to an accuracy of 2 decimal places. Therefore, now that the two measurements are recorded in two different accuracies, then we shall have two different absolute errors in the recording of the two values. For example, A is going to lie between, the limit of A will be 2.5. And now, because we have an accuracy of 1 decimal place, which is 0.1, divided by 2, we add 0.05 as the absolute error in the recording. So we shall add 1 or 0.05 or subtract it to get the limits within which A lies. So this is going to be 2.45 up to 2.55 as the upper limit of A. On the other side, we got B. Because we have two decimal places, then an absolute error in the recording of 0.01 divided by 2, which is 0.005 is the absolute error in the recording of the figure of B. So 6.15, we add or subtract 0.005. This is going to land as at 6.145 up to 6.155 as the upper limit of B. Now that we have the limits within which the dimensions have been recorded, I think we can get now the errors whereby we will first of all get actual difference. The actual difference, whereby we will just take the measurements as they have been recorded, we subtract them. 6.15, we subtract 2.5. This is taking us to 3.65. Then we again get the maximum difference, whereby we will get the largest value in B, 6.155, and we subtract the smallest in A, 2.45. This will give us the maximum difference because we have used the maximum value here and we are subtracting the least value in the other case. So now we will get 6.155 minus 2.45. This is taking us to 3.705. Then we still have the minimum difference between the two values. We will get now the least value in B, 6.145, and we subtract the largest value, the greatest value in A, whereby it will be 2.55. This will give us the minimum difference between the two figures. So 6.145, we subtract 2.55. This is taking us to 3.595. So we have now maximum, minimum, and actual difference, which means now we can get to the calculation of different types of errors. There is what we call absolute error in propagation of errors. The absolute error is given by the difference between maximum and minimum divided by 2. 3.705 minus 3.595, we divide by 2. This is going to be 3.705 minus 3.595. Then we divide by 2. This is going to be 0.0 0.055, the absolute error. It is very important to know that the same absolute error can be obtained by taking actual value minus the minimum value, or maximum value minus the actual value. They will give us the same absolute error. This is guaranteed because when we take the maximum, when we take the actual, and we take the minimum, we realize that the actual is exactly at the mid of maximum and minimum. Therefore, taking maximum minus actual will give us the same value as taking actual minus minimum, and that value will still be the same as maximum minus minimum divided by 2. It will just be the same value. After this, we get percentage error now. Percentage error, which is given by, when we take absolute error 0.055 divided by actual difference, which is 3.65, this alone will give us what we call relative error. But now when relative error is multiplied by 100%, it gives us percentage error. Divide this by 3.65, then we multiply by 100. The percentage error is going to be 1.507. This is a percent, correct to 4 significant figures. Thank you for following. Subscribe and share.